we're going to do is that we are going to look through some code first to set some metadata. So you need to create a .env file like this one, and you need to put a private key, the private key, your MetaMask private key in it, like that. So like the wallet on your MetaMask that you created, you already did it. I'm not going to show on the screen, although it's like just test leaks, but it's like yeah, you just put like you just create .env file, and you take your MetaMask private key and you pasted it, and then we're gonna get started. So like basically, so it's gonna be import. I think it's env from .env. How was it? Oh yeah, config. It's config. So config as load config. So this is just to load our environment variable. And so the first thing is that we are going to do, we're gonna create a function to deploy my token. So in order to deploy our token, we have to first get the ABI of a smart contract. So we're going to say LSP7 artifact from the same package that we used before, LSP7 contract / artifact / LSP7 mintable.json. Okay. So then we're going to use ethers.js. We're going to do ethers from ethers, and we're going to do my token equal new ethers contract factory, and the contract is going to require two things: the ABI of the contract and the bytecode. So in the artifacts that we shipped in the package, we have both of them. So LSP7 artifacts ABI, LSP7 artifact bytecode, and then the third parameter is the runner, meaning the provider. So the provider here is going to be the private key that you funded on your with some test leaks. So we're going to do signer. Yeah. So yeah, first of all, we need to load the provider. So new ethers JSON RPC provider, and I think the address is https:// it's rpc.testnet.luxo.gateway.fm. And then for the signer, we're going to do new ethers wallet, and same the private key. We need to load the private key. So process.env.private key. Yeah, we need to cast it as string, and we need to pass a provider to say this is the signer connected to this network. Okay, so far so good. Yeah, so I can just load. So like yeah, here we're going to call that my token factory. And then we're going to do my deploy token. We're going to do await my token factory deploy, and then we need to pass the arguments. So the arguments are going to be yeah, sorry, actually it's not LSP7 artifacts, it's actually it's the contract that we created. It's this one. So it's going to be, so yeah, you see the contract that you created in the previous one. Now it's available under artifacts, contract, I get to ERC2 SP, ERC22 LSP7, and it's going to be we go coin as LSP7, sorry. As LSP7. Echo coin artifact. Okay. And then we're going to deploy, we're going to use this one. I had already done it. So yeah, the only thing we need to pass here is basically the initial owner, and the initial owner will be the address of the signer. Okay, and then we're going to do await my deployed token, wait for deployment. We can just log deploying token contract. Emoji everywhere. EchoCoin deployed at my deployed token. Here, up here. Okay, and here I will do. Yeah, we double check it's. It should be. Yeah, that's good. Yep. Okay, then we just going to run the script. npm run. Deploying my token. Oh yeah, no, sorry, it's npx hard hat run. Oh yeah, sorry. It's I need to go inside the hard hat project. Yeah. Okay, let me say, what is it? Send transaction. Did compile. What did I do wrong here? Let me see compared to. New if JSON RPC provider if okay. I forgot that. Yeah, so that's how it works in IFRv6. And if we go into the LUKSO testnet, we will see we have deployed 18 seconds ago. This is the contract. Yeah, so that's that's basically it. We deployed the token contract. Yeah, I think I will not be able to do every single code snippet live, so I will probably go rather through the code example. Yeah, so we said the first thing that we have about the token contract is on LUKSO is the metadata. So basically the LUKSO token, they have like an unlimited amount of metadata, meaning you can basically set under the hood of a contract storage, you can set any form of metadata. So anything like the name, the symbol is in the metadata, but you can add things like the creator or any other optional information. And the way you do that in TypeScript is the following. So like you can read from the contract storage, like the metadata, or you can write to it. So like here, like I'm reading the name and the symbol. So the way we do it is just we do the instance of a token contract, get data, and then we get bytes and we decode it. And same for the symbol. So I will just run this one first. And I will actually put this address instead. So if I do this, npx run. So you see, like, I got basically, so this is the way it works. Like all the token standards on LUKSO have things like what we call metadata. So metadata is basically a schema to describe what an entry in the contract storage represents. So this is the name of a key, the token name. This is the raw, this is what the smart contract understands. The smart contract understands like the byte 32 keys. And what get returned under the hood is encoded as a string. So to get it very readable way, we decode it as a string, which is what I technically did here. So I converted it with the ether.js function to TF8 string. And same for the symbol, and we got that back. So now that we did the reading the data, we're going to do the writing the data. So so the way it works is that we could do things like base URI. I mean, here it's an LSP7, so it doesn't really apply. But we can set things like the base URI for a token, an NFT collection, or we could set the metadata. So this is like a sample value. Or we could set the list of creators who created the asset. So like this is useful for things like, for instance, like if we go into the actual PP browser extension, you can see like the creators, how they relate. So for instance, this is like my NFTs, and when you register the creators in the token contract and the creators register the token they issued, then in our Explorer you can see that they are verified creators. So like this is just the proof that I own NFT that come from the legitimate sources.